Homework 3.2, Polynomial Functions, Video 9. Homework due Wednesday, May 27th, 2020 at 11:15 p.m. 11:59 p.m., excuse me. This problem is associated with homework questions 10 through 14. Alright, so the fourth polynomial function that we analyzed was j of x equals negative x to the fourth plus 9x to the third plus 6x squared. We had already analyzed that its end behavior is both in small, that it had two x-intercepts at 0 and 3, and at both x-intercepts it touched and turned. And my apologies, this is not the function. The coefficient of x cubed should be 6, and the coefficient of x squared should be negative 9. My apologies. And for the squeaky shoes also. Alright, so let's figure out the things we don't know. Maximum number of terms. The degree is 4, so 4 minus 1 is 3. Is this even, odd, or neither? Well, if a polynomial function has a combination of even and odd powers, it will always be neither. So no symmetries, or no y-axis symmetry, no origin symmetry. This graph actually has a symmetry. I'll show you where it is. What's the y-intercept? Well, plugging in 0 will give out 0, so that's easy. So let's put it all together. All right. So we have both ends falling, so I'm going to draw arrows pointing down. We have a y-intercept at 0, that's also an x-intercept. We have an x-intercept at 3. The graph touches and turns at both x-intercepts. So, here we go. Start low, touch and turn at this x-intercept. As I go down, I'm going to have to turn around and come back up. Without calculus, we can't really know where this does turn around. I happen to know it turns around at 1.5, but let's not worry about that. Touch and turn and go back down. This is the graph that I had incorrectly drawn in the first video and corrected at the beginning. I'm sorry, incorrectly drawn in the second video and corrected on the third video. And although this doesn't have y-axis symmetry or origin symmetry, this particular graph actually does have a line of symmetry right down the middle at 1.5, but don't worry about that. You won't be held accountable for other symmetries. But it bothered me saying that this graph has no symmetry. Proving that some axis of symmetry is another story. It did turn 3 times, and everything else is good. So again, the hardest part about these is gathering all the information, but once you put it all together, it's pretty easy to finish off the graph.